everyone. Welcome to Smart YouTube channel. Please subscribe and hit on the bell icon next to the subscribe button to get new videos. This video is for the grade 10 mathematics students who are studying the Lankan syllabus. In this video, let's study the first lesson of the grade 10 textbook, that is perimeter. At the end of this lesson, you will be able to calculate the perimeter of a sector of a circle and to calculate the perimeter of plane figures which contain sectors of circles. Guys, what is perimeter? Basically, what is meant by perimeter is the total length of the outline of a shape, or else in much more simple way, it is the total distance around a particular shape. As I told, the perimeter is a total distance around a given shape. Here you can see how I have calculated the perimeter of this given shape. Simply, I add the lengths of the four sides. Here, this is a rectangle. It has two lengths and two widths. So to get the perimeter, I add the two lengths plus the two widths, that is 10 plus 10, that is the length, plus 5 plus 5, which is the width. Altogether, when I add, I get 30 feet as the perimeter. First, we will see how to calculate the perimeter of plane figures. You have done this in your previous grades, so you must be knowing these by now. But anyway, let's quickly go through them just to revise. What are plane figures? A plane figure is any figure which can be drawn on a 2D plane. Simply saying, it is a figure that can be drawn on a paper. Here I have shown some examples of plane figures like the rectangle, triangle, circle and square, etc. So here, let's see how to calculate the perimeter of some simple plane figures like the square, rectangle, triangle and circle. In a square, all the four sides are equal. So you can calculate the perimeter of a square by adding the four sides. So in this case, the length of one side of a square is A. So A plus A plus A plus A gives the perimeter of a square. Simply you can say the perimeter of a square is 4 times A, that is 4 times one side. In a rectangle has a length and a breadth. Two sides are equal. So to get the perimeter of a rectangle, you can add the 2 length plus the 2 breadth. So the perimeter of a rectangle is given by 2 times the length plus 2 times the breadth. In a triangle, the perimeter is calculated by adding the 3 sides, lengths of the 3 sides of the triangle. So here in this case, the perimeter of a triangle is length A plus length B plus length C. When you consider a circle, the perimeter of a circle is calculated using the equation 2 pi r. Let us look at an example. You have to find the perimeter of the given figure. To make it easy and to understand better, I have labeled this figure with points from A to G. The perimeter of this is calculated by adding the lengths AB plus BC plus CD plus DE plus EF plus FG plus GA. That is how you get the perimeter of this figure. So to calculate the perimeter, we should know all those lengths. Right? So, but they have not given all the sides. They have just given only a few sides. So we have to find the lengths of the other sides as well. They have given that side DE is equal to the side BC, and that is equal to AG as well as GA. So DE is given as 3 centimeters. Since DE is equal to BC, AG and GH, all these sides are 3 centimeters. Side FH is given as 4 centimeters. Therefore, side AB is also 4 centimeters. You can see the AB is equal to FH. Then side EF is equal to side CD. Therefore, EF is given as 6 centimeters. So CD is also 6 centimeters. Now we have found all these lengths except for FG. Right? So how can you find this FG? That is a bit different. So let us now see how to find FG. Here you can see FGH is a right angle triangle. So to find FG, we can use the Pythagoras Theorem. In a right angle triangle, this longest side is called the hypotenuse. So in this, the hypotenuse is side FG. What does the Pythagoras theorem say? In a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. That is the Pythagoras theorem. So in this case, when you apply the Pythagoras theorem, the hypotenuse is FG, so FG squared is equal to the sum of squares of the other two sides, that is GH and HF. So FG squared is equal to GH squared plus HF squared. GH here is given as 3 centimeters, HF is given as 4 centimeters. So FG squared is equal to 3 squared plus 4 squared. That is 9 plus 16, which is 25. So FG is the square root of 25, which is 5 centimeters. So now that we know FG, we know all the sides of this figure. So we can easily calculate the perimeter of this figure. And so side AB is 4 centimeters, BC is 3 centimeters, CD is 6 centimeters, DE is 3 centimeters, EF is 6 centimeters, FG is 5 centimeters, GA is 3 centimeters. So by adding all the lengths, you can get a perimeter which is 30 centimeters. Now let us move on to calculating the perimeter of sectors of circles. When considering about circles, there are some terms you need to know. Circumference. Circumference is the perimeter of a circle. That is, this length of the boundary of the circle. This is the circumference. Then the center of the circle. That is the center point of a circle, and it is denoted by C or sometimes by O. Then this is the diameter. The diameter is the length of a line between 2 points on a circle which passes through the center point of the circle. Then this is the radius. The radius is the length from the center of a circle to a point on the circumference. This image here shows a sector of a circle. This is a sector of the circle. So what is a sector of a circle? A sector of a circle is a portion of the circle which is surrounded by two radii of the circle and the arc between the two radii. So a sector of a circle is surrounded by two radii. This is the two radii, and arc which is between the two radii. What is an arc? Arc is any part of a circle. Like in this figure, AB is an arc. Or even this is an arc. And not only this, even this is an arc. And the arc length is the length of this arc AB. Then this is the angle at the center. It is denoted by theta. This angle at the center is the angle which is formed at the center by the two radii. This is the two radii, and this is the angle formed by the two radii at the center of the circle. This angle at the center can vary from 0 up to 360 degrees. When this angle at the center is 360 degrees, it is a complete circle. And when the angle at the center is 180 degrees, it is a semicircle. And also when the angle at the center is 90 degrees, it is a quarter circle. To calculate the perimeter of a sector, you have to first find the arc length. You should first find this arc length, and then you can find the perimeter by adding the arc length and the two radii. Why? Because this sector is surrounded by the two radii and the arc. So the perimeter is given by the total length of the two radii and of the arc. So you should first calculate the arc length, then you can add the arc length plus the two radii. Now here we are going to see how to calculate the arc length of a sector. Let's just consider symmetry. Here you have a semicircle. Semicircle is half of a circle. According to the symmetry, semicircle is half of a circle. So the circumference of a semicircle should be half of that of a circle, right? The circumference of a circle is given by 2 pi r. So if the circumference of a semicircle is half of that of a circle, it should be half of 2 pi r. That is pi r. Similarly, in a quarter circle is 1/4 of a circle. So the circumference of a quarter circle should be 1/4 of the circumference of a circle. Right? Then the circumference should be 1/4 of that of a circle. The circumference of a circle is 2 pi r. So the circumference of a quarter circle should be 1/4 into 2 pi r, that is pi r by 2. So here what we consider is, by looking at the symmetry, is the arc length as a fraction of the total circumference. In a semicircle, the arc length as a fraction of the circumference is half. In a quarter circle, this arc length as a fraction of the total circumference is 1/4. Now we will look at the angle at the center. In a circle, the angle at the center is 360 degrees. In a semicircle, the angle at the center is 180 degrees. Now 180 degrees is half of 360 degrees. So the circumference of a semicircle is again half of that of a circle. How we get that half is 180 degrees in a semicircle, angle of a semicircle, over 360 degrees, which is angle of a circle, into 2 pi r. So that is half into 2 pi r, which is pi r. In a quarter circle, the angle at the center is 90 degrees. 90 is 1/4 of 360 degrees. But how we get that 1/4 is 90 degrees divided by 360 degrees, you get 1/4. So then similarly semicircle, here the arc length of the quarter circle is 90 over 360 into 2 pi r, that is 1/4 to 2 pi r, which is pi r by 2. So here we consider the angle at the center as a fraction of the total angle at the center, that is 360 degrees. By considering the angle at the center as a fraction of 360 degrees, that is the total angle at the center, an expression can be obtained to find the arc length of a sector having a radius r and angle at the center of theta. The circumference of the circle is 2 pi r. The arc length, we can take it as theta over 360 of the circumference. So circumference is 2 pi r, so therefore the arc length is equal to theta over 360 into 2 pi r. This is the expression to calculate the arc length of a sector. Let us look into an example. This is a sector of a circle having a radius of 35 centimeters and an angle at the center of 240 degrees. The equation we use to calculate the arc length is theta over 360 degrees into 2 pi r, and we consider pi as 22 over 7. The angle theta is 240 degrees, so 204 arc length equals 240 degrees over 360 degrees into 2 pi r. When you simplify this, 12 times 2, 12 times 3, 2 over 3 into 2, pi is 22 over 7 into r is 35. So 7 times 1, 7 times 5. When you multiply this, you get 240 over 3. That is 146, 2 over 3 centimeters. This is the arc length of this given sector. This is another example, and this is a sector of a circle. But here they have given the angle, not the angle of the sector. They have given this outside angle. And the radius given is 10.5 centimeters. So you know the equation to calculate the arc length. And we take pi as 22/7. So you can calculate the arc length in this way. The theta is not given. So theta you have to find. Theta, this angle is theta. This angle is 360 degrees minus this angle. That is 360 degrees minus 60 degrees is the theta. So that is 300 over 360 into 2, pi is 22/7 into 10.5, that is the radius. So you can simplify this and you get 55 centimeters as this arc length. Now let's calculate the perimeter of a sector. I already explained how to calculate the perimeter of a sector, that is the arc length plus the 2 radii. When considering a sector of a circle of radius r and an angle theta at the center, you can use this equation to calculate the perimeter of that sector. Theta over 360 degrees into 2 pi r, that is the arc length, plus 2. Let us look at this example. This is a sector of a circle having a radius of 7 centimeters and an angle at the center of 200 degrees. So here you have to find the perimeter. Perimeter is the arc length plus 2 radius, 2 into radius. Perimeter equals theta over 360 degrees into 2 pi r plus 2r. You know theta is 200 degrees and r is 7 centimeters. So you can calculate the perimeter of this sector. Let's look into another example. In this example, they have given the perimeter and the angle at the center. You have to find the radius. You can apply the theta and perimeter values to the equation and you can get the radius of the sector. Perimeter is given as 180 centimeters and the angle at the center is given as 180 degrees. So you can apply it to the equation. Theta is 180 over 360 into 2 into 22/7, which is pi into r, because we don't know r, we have to find r plus 2r is equal to 180. So when you simplify, you can get r as 35 centimeters. In this example, they have given the perimeter and the radius. We have to find the angle at the center. Perimeter is given as 64 centimeters and radius is 21 centimeters. So again, you can substitute these values in this equation and you can find the value of theta. Perimeter is 64. 64 equals theta over 360 into 2 into 22/7 into 21. That is the radius plus 2 into 21. When you simplify it, you can get theta as 60 degrees. By now, you know how to calculate the perimeter of a plane figure and also you know how to calculate the perimeter of a sector of circle. Now, we are going to calculate the perimeter of figures having both plane figures and sectors of circles. So, we'll move on to an example. Look at this question carefully. It says that the figure illustrates an equilateral triangle of side length 7 centimeters. So here I have drawn another figure indicating all this data they have given. So here I have marked the side lengths of this triangle. It is an equilateral triangle, so all three sides are equal. This figure they have given is a sector of a circle. So this length AB is O, length BC is the radius of this circle, and that radius is 7 centimeters because they say that the side length of an equilateral triangle is 7 centimeters. In the first part, we have to find the arc length of the sector, and in the second part, we have to find the perimeter of the shaded region. We have to find the perimeter of this shaded region and not the perimeter of the sector. First, finding the arc length. You know the equation to calculate the arc length. Theta is 60 degrees. Why? Because it is an equilateral triangle. and r is 7 centimeters. So you can substitute theta and r to get the arc length. 7, arc length is 7, 1/3 centimeters. Then you have to find the perimeter of the shaded region. The shaded region is this region. So the perimeter of this is this length of the AC straight line and the length of the AC arc. We already found the length of the AC arc in the first part, and we know that the length of the straight line AC is 7 centimeters. So the perimeter of the shaded region is 7 plus 7, 1/3 centimeters, which is 14, 1/3 centimeters. So now we have come to the end of our lesson, and looking back at what we have learned here in this lesson, we learned how to calculate the arc length of a sector of a circle using the equation theta over 360 into 2 pi r. And also we learned how to calculate the perimeter of a sector using the equation theta over 360 into 2 pi r plus 2. So basically that is a summary of what we learned today. Thank you guys for watching, and keep watching our other reviews as well.